Assalamu Alaikum. Welcome to Programming Concepts. I am Sayyid Naveed Abbas, and in this video I'll be showing you how to create a skin diseases image classifier in Python using TensorFlow. So for this, we shall be required to download this dataset from Kaggle. So I'll put this link in the description. You can download this dataset. Let's take a look on this dataset. So there are two directories, one for testing. So it will be having fewer files for testing our classifier. So once we have trained our classifier, we can test our classifier using these images. So you can see this one, this is the Acne category, and you can find these images here. And then we have hair loss, nail fungus, normal, and skin allergy. Okay, back there we have train, and you can see there are more files than the test category. So we shall be using these images to train our model. So let's download this dataset. I have already downloaded this dataset and put it in here. I have this folder called skin diseases, and I have put the dataset here. Now let's open the Visual Studio Code and start coding. First, we shall be creating a train.py file. So in this file, we shall put all the code for training the classifier. In TensorFlow, there is a model which is called VGG19. So this is the structure of a deep learning model, which can be used to train images, and it is of course a CNN model. Then we shall be having different layers in our neural network, and these layers will be performing different operations. So we shall be using these layers: average, pooling, 2D, dropout, flatten, dense, and input layer. And then we shall be having a model class. We shall be using TensorFlow Keras models. We shall also be using optimizers for training. So optimizers optimize the training process. The optimizer that we are going to use is add. And then we have two categorical function or class, which we import from Keras utilities, and this one is for preprocessing. I will tell you what it does. Then we shall be using Scikit-learn preprocessing for label binarizer, and some other tools like train and test split, classification report, and confusion matrix for post-training evaluation. Then we shall be using some other tools like image utilities, matplot library for plotting the training and testing history, NumPy and argument parser, OpenCV, and operating system. Now, if you don't have any of the above libraries, you can download them using pip command. So all you need to do is open cmd and type pip install numpy. As you can see, I have already downloaded these libraries, so I don't need to download. You can do the same for all the above libraries. So we close this. Now we shall be constructing the argument parser for this program. So this will be the argument parser. In this, we shall be providing the name of the dataset. So as you can see, we have dataset directory, and then in this directory we have a subdirectory called train, and this directory contains more directories with the dataset. Okay, so we have provided this as a default dataset input. Then we shall be providing it the name of the plot. This plot will be containing the history of training and validation. And at the end, we are providing the name of the model that we want to be exported. Now we need to create two lists for loading the data. So I shall be creating two lists, one for the data list, and the other will be labels list. So the data list will be containing the images. For example, we have this image, which is 21.gif. Okay, we have this image name, and then we shall be having its label, so it belongs to Acne. So in the same way, all the images will be loaded, and then we shall be having another image from nail fungus, which will be like something like 1 into 1.gif, and this belongs to nail fungus category, nail fungus. Okay, so in this way, all the images will be loaded, their names and their paths will be loaded in the data, and their label will be loaded here. Now we need to create some essential variables for training. So these variables will be initial learning rate, number of epochs, and batch size. So we can change these values according to our requirements. So this changing these variables will affect the training process. Okay, now we start loading the images. Okay, we shall be loading the images from the dataset folder that is provided through the arguments. So once we create a list of that, and we will get all the image paths into this variable. Next, we need the mechanism to load all the images and their labels, the name of their folder, into labels list. So let's create that. So for all the image paths in this variable, we extract the label. So we split the image path, and then we have the second last thing, which is the name of the folder. Next, we read the image file from that path and save it to the image variable. We shall be using the image read function from OpenCV. Then we convert the BGR channel of the images to RGB and resize the image to 224 by 224. So this resizing is important because these images will be input into the neural network, and the size of the neural network's input is mostly 224 or 226, around this. Then we put this image into the data, and we put the label into the labels. So we are not just saving the path of the image, we are actually saving the data of the image into the data. So let me show you how this happens. Let me show you how it looks. So for every image we process, we print the data of the image, and we also print the label of the image. Okay, now let me run this code. I go here, terminal, and I write Python train.py. Okay. So I didn't specify anything in the argument parser because we already have the default values. So you can see for each image, the loop is running and loading the data. So I'm going to cancel it. And you can see that for each image, you can see this is the image data for each channel. So first pixel and its red channel. Second, for each pixel there's R and G and B data. So this is red and green and blue, red, green and blue, red, green and blue, and for the whole image. So these will be 224 matrices for a single dimension. So it is 224 by 224 image. So there will be 224 by 224 pixels. So this is just a single pixel. I hope you understood what I'm trying to say. We shall be scaling the image data and labels. So we are scaling the pixel intensities from 0 to 255 intensities. Then we perform one hot encoding on the labels so that we can put these labels, which are in English, into something that can be provided to the model for better understanding. So these labels will be converted into numbers instead of the simple English words. Now we put the labels into categories. So after we have converted them into numbers, we shall be categorizing them so that the same category is recognized. Next, we prepare the dataset for training. So we shall be splitting the dataset into train and test sets. So we are keeping 20% of the dataset for testing and the 80% for training. Next, we shall be performing training augmentation. Training augmentation can be used to modify the input data so that we train this model for every scenario possible. For example, we are going to rotate our images to 15 degrees, and then we shall be using fill mode as nearest. So this means that when the user gives the image which is rotated, so our model doesn't just get confused. So it also to make it able to understand the rotated image, we perform this training augmentation. Next, we prepare the model. So we call it base model, and as I have already told you, we're going to use VGG19, and its weightage that we are going to use our image network, and on the top of this there will be no layer. There will be no layer on top of this. So this will be the first. Okay, and then the size of the input tensor would be 224 by 224, and 3 is the number of channels, red, green, and blue. Now let me show you the structure of this VGG19 model. So here this image shows the structure of VGG19 model. So we have this input image, and this input image will be passed through convolutional layers of this model. So you can see there are many layers performing different operations like max pooling, max pooling, max pooling, max pooling, flattening, and then these the neurons are connected to one another, and then they output the data. So this is the structure of VGG19 model. Our image will pass through this model, and then we shall be creating another network, custom network that will be used to train. So we are not going to modify the weightage of this VGG19 model, but we shall be adjusting our the weightage of some new layers that we are going to create for the training. So let me show you how we're gonna do that. Come back here. So here we have specified our custom layers of neural network. So there's a head model, and the head model will be actually the output of the base model. So once the image has passed through VGG19, it will come here, and then we shall be performing average pooling 2D, then we shall be performing flattening, then we shall be performing density, like dense, then dropout, then dense again. So dense actually specifies the number of neurons in that layer. So we have 128 here, 64 here, and 5 here. So this is the last layer of the model. So here you can see the above layers are using rectified linear unit function as activation, but the last one is using softmax. Also, the number here, the number of neurons here should match the number of classes in our target. So you can see 1, 2, 3, 4, 5. So we must write 5 here. Now we pack everything into a single model. So we create a model, and using the Keras model class, and then we put the inputs as base model input and outputs as head model output. So here's the thing. The input of the model is the input of the VGG19 model. And then when it goes through the VGG19, then it comes here. And then the output is the output of head model. So this is the starting point. Then this is connected to here. And then this is the output. I hope you understand. The input is the base model's input, and the output is the head model's output. Now, as I have told you already, that we are not going to train or modify the weightage of base model. We are not going to adjust weighting of VGG19. It's perfect as it is. We are going to train here. So we shall be adjusting our weightages here. Okay, so we specify that do not train the base model layers. They are just for processing. Okay, next we provide the optimizer that we are going to use with the model. And then we compile the model. We provide the function of loss, that how we are going to measure the loss, also providing the optimizer, and also providing the matrices that we are going to evaluate our model with. So we are going to prefer the accuracy. So we need more accuracy in our model. Now we train the model using model fit generator function, and we provided the augmentation function. Also provide the train X and train Y data, batch size, and we calculate steps per epoch, and validation data and validation steps. Also, we provide the number of epochs. So this function will try to this function is going to train the model, and the history of this training will be saved in hatch variable. After the successful training, we shall be evaluating the network using the test split. So as I have also told you that 20% of the data was reserved for testing, we shall be using that 20% for testing. So we shall provide the test data, batch size, get the result in prediction indexes. The neuron with the highest probability will be selected, and then we shall be saving the model. So here we save this model, the trained model, into our hard disk with the name provided in argument parser. Next, we print the classification report. So we provide it with the actual results and also with the predicted results, and then it will provide us the classification report. Also, we shall be using confusion matrix function. We shall also be providing it the original results and the predicted ones, and it will provide us with the confusion matrix. I shall explain what these two things are later in the video. Next, we shall be printing the accuracy, sensitivity, and specificity. Then we shall be printing the plot for the history of training. For this we shall be using the matplot library, and then the program ends here. So now let me run this code and see what happens. So open the terminal, save the file, open the terminal, and write down Python train.py and enter. Let me cancel this. The printing these values will take a lot of time, so let me delete this. Okay. Okay, now save this one and run this again. Now the images are being loaded, and there is an error. It says image data generator is not defined. Let me see if I have included all the necessary libraries. Okay, we are missing the data generator. Let me import it here, save it, and run this again. Okay, we can see the training has been started here, and this takes most of the time because it depends on the computer's capability of training the model. So I'm using i7 9th generation processor with NVIDIA GTX 1650, and I have installed TensorFlow for GPU and NVIDIA CUDA and CUDNN. You can see here that in the initial steps, the loss was highest and the accuracy was the lowest. But as soon as the system is being trained and it's adjusting its weights, we can see that the loss is decreasing and the accuracy is increasing gradually. So this means our neural network is training well. If you don't see this, if you don't see loss getting decreasing, or if you don't see accuracy being improved, then it means that your neural network is not performing well, or it is not being trained. So there may be anything wrong with the data, anything wrong with the structure of the neural network, or with the main model that is being used. Okay, the training has been completed and we can see the results here. So this is the classification report, as you can see here. So it says Acne, there's 84% precision, 96% recall, and F1 score is 90. Support means the total number of images that were being tested. So there were a total 27 images from Acne category. Hair loss 21. The F1 score is 98%. Recall is 95%. Precision is 100%. And so on the nail fungus, normal, and skin allergy. Here we can also see the confusion matrix. This is the confusion matrix, And the main thing that we need to remember is the diagonal of this confusion matrix should contain the highest numbers. Okay, now this is our confusion matrix. What it means is 26 plus 0 plus 0 plus 0 plus 1, 27. So there were total 27 pictures that were given to the system for testing, which belonged to Acne category. And here it means the number of images identified as Acne. So total were 27. 26 were identified as Acne, but one was identified as skin allergy. So because both of them were similar, because acne on the skin and also the skin allergy somehow matched. Then hair loss. So there were a total of 21 images, but 20 were classified as hair loss, but one was mixed with normal. Also the nail fungus. So there were total 34 images that belonged to nail fungus, but 33 were identified as nail fungus, but one was identified as normal. In the same way, there were 30 pictures that belonged to normal category, but the system identified one image as acne and 29 images as normal. Then skin allergy. There were 39 images that belonged to skin allergy category, but 4 of them were identified as acne, one was identified as nail fungus, and 34 were identified correctly as skin allergy. So that's why it's called confusion matrix. By getting the confusion matrix of your model, you can identify how much confused is your AI model. Okay, now we discuss the plot. So plot is a PNG image that is exported. You can open this image. Okay, here and see that the loss decreased gradually and the accuracy improved over time, and this is the percentage. So this is more than 90%. So accuracy of our model is more than 90%, and the loss is about less than 10%. So our model is trained well. I hope you enjoyed this tutorial. In the next tutorial, I will create another Python file to deploy this system. So we will be using other images from the internet and give them to our model and see if our detector can detect skin diseases from new images. So until then, take care. Allah Hafiz. See you in the next video.